Okay, welcome back to the second part. So the first part largely talked about the high-level view and how elements like, cloud computing, high-performance computing, big data, machine learning, deep learning, all of these elements are somehow, in a way or another, connected to each other. And so this should be really thinking as technologies that in a way go together these days. And then, of course, applications are very important. So we will here and there use some of the applications that you have seen, remote sensing, but also others from machine learning in order to show and demonstrate the impact of clouds. The second part now should largely go over the course organization before we enter then the Q&A session. Where you can also have already questions noted now in the chat, and I will come to them back later. Maybe short feedback. Can you hear my voice right now?
Yes.
Okay. Yeah, excellent. Thank you very much. So we have the second part, entering, of course, with lecture 1, where we then see that, basically cloud computing was starting not from the skies or somewhere in the clouds. It rather had evidence of a long history of technologies down to earth, so to speak. As I said earlier, grid computing was a predecessor, and if you want, also cluster computing. And in a way, all what's around networking is also a very important part of this. So we look a little bit on the evolution of cloud computing. And of course, then that are things you really want to know. If you go out in the job market, things like Amazon Web Services, we have lots of examples in the course again and again, Rackspace, Facebook, Salesforce, even IBM has clouds. So these are things which you really need to know by heart if you're down and out there in the commercial field. We shed also some light here and there on the academic field, so European Open Science Cloud Services and so forth, particularly also showing how you in Iceland get connected to EOS Nordic and so forth. Underneath, we will have then in the first lecture really some baseline technologies. It's just needed to really understand a little bit what, how cloud's really working. You see, it's really decentralized, it's scalable, so it needs technologies like parallel computing, cloud computing, which is enabled by distributed computing and things like that. So for this, we also have to understand some of the technologies underneath this, looking really shortly inside what is a cluster, what is a node, what is a parallel computing entity. And if we break up these clusters, then we see underneath it's just things multi-core CPUs. In every laptop today are usually multi-core CPUs, and even you have some which has GPUs. So you will see these technologies are not very, very different than those If we have memory, we have storage, we have interconnects, network, but of course it's more dense and it's more put in a way that's really scalable in certain technologies, which really we will look at, and particularly also looking around things like energy efficiency. GPUs are, for instance, very energy efficient, have a very low energy footprint. Things like this we will a little bit look in lecture 1 so that you understand the baseline. More technicalities and technologies then in this regard are really taught in the high performance computing, where we go one level deeper, so to speak. Cloud computing is one level higher if you want, and the same goes for programming, as we heard from one of the questions. So here in this course will be not much programming, would be rather walkthroughs. So still, also the first lecture will give you an introduction of the big data part of it. So what's the problem with it? What are the impacts of big data? Volume, velocity, but many others. Value, if you lots of nonsense data, big data could be lots of noise in it, lots of data you're not interested in, and just a couple of fractions. So how to extract them? There were new programming models, the analytics, which really provides infrastructure. That's what we do in lecture 1. And you will see also already next week, we will start with a lecture 0.1, where I do a practical lecture, essentially just hacking for you a little bit, showing you some Python codes and scripts to get familiar a little bit with Python, with NumPy, with Jupyter, while then lecture 2 kind of assumes this knowledge. These practical lectures are a little bit more like a webinar where you can also ask questions And usually they're very useful for your assignments, because in a way or not, I will sometimes present very similar things you have to do in an assignment, like executing some machine learning code in the cloud using Jupyter notebooks. And these are sometimes even voluntarily. So practical lectures means if you're very keen on using Python daily, on knowing everything about Jupyter notebooks, for instance, you don't need to participate next week, Tuesday. So, but of course, for those of you who have never programmed with Python a little bit, although programming is a little bit, it's a scripting language, so it's not really like C or Java or something like this. Still, you need a little bit the modus operandi of it, importing different libraries and so forth. And Jupyter is a very neat way how we get access to computing resources while still, in a way, having a very streamlined way of executing Python code on our systems itself without having the need for having too much SSH and so forth. So other low-level protocols which are usually needed. And with this, we have always practical lectures, or I show a little bit how it works with Azure, or I show a little bit how it works with Amazon Web Services. So these are lectures which are now not here in this overview. Here we just have the real, let's say, fundamental lectures, and you can see that practical lectures will be alongside the way to really support your assignments or to support some practical aspects. If you want to know a bit more about the practical lectures, you can go back 2 years and go to my website. There you find the course from 2018 and also practical lectures as well. And very similar lectures we have these days. And although the course has some prerequisites, we can always assume there are some people that never use Python, others never used JupyterLab or Jupyter Notebooks. Some people don't use machine learning. So that's why we here and there have to do some practical lectures to get everyone more or less up to speed on the same aspects. And lecture 2 then will really introduce machine learning, but on a very moderate level, right? So this is not something where we say everybody out of this lecture will be a machine learning expert. Otherwise, this course would have called machine learning. But here we really want to position it as a application technology where you can make sense out of big data, what you can, use big data with. And there will be different phases like training, testing, validation, which we will reflect a little bit. We will see on some of the very trivial models of machine learning, like a regression model, for instance, for multi-class classification. Also there, we don't really start directly with a deep dive in deep learning, rather keeping on the model scale here, having linear learning models first to really understand the machine learning and how it's done in clouds. And usually how it's done in clouds is coming back to the practical lecture. So you would have some form of a Python environment. You have some form of a cloud service you can connect to, you can use. That is already prepared for either providing you put in a notebook with the necessary libraries for machine learning, or gives you, let's say, access to some higher level service that has already lots of substance for machine learning included. Amazon is a very good example of that. It has lots of machine learning services already running that you can just use. So of course, it is a cloud course, so we will put also an emphasis on this, but some fundamentals about machine learning to know now is very good, because it also gives you a light maybe for the future to see if that's something you want to go for. Because having known about cloud computing and big data, a very interesting, nice step is to know more about machine learning and deep learning and go to the job market. And then you have really good jobs with lots of high salary. Then having started with the machine learning overview and how you use it in clouds, we will look on one specific, very known application enabler, basically in clouds, which is the Apache Spark system. So Apache Spark is an open source tool which has been used by many different cloud vendors in the past and is used today also with lots of different applications, domains. The kind of idea why it's so successful is that it has some resiliency inside with resilient distributed data sets. So things that fail on this infrastructure can basically be restarted, and the error handling and the fault tolerance is relatively quite high. You have an interesting set of libraries, as you see here, You have not only typical SQL, structured query language to connect to databases, but also machine learning library. As I said, also more popular these days get graph databases, not only for social networking, also for many other problems you can apply graph or graph libraries. And also Spark streaming might be something you could look in, for instance, when it's about high velocity data and you don't want to keep everything, you just want to have some events or some filters. When you think about a Twitter tweet stream, would be one example, and you're just interested about the things that are told about the University of Iceland, for instance. So this is something where you could use these technologies very quickly in an automated fashion. And we will learn about this technology step by step and how it relates to other aspects. But this will be also part, the substance of lecture 2 and 3 really for your first assignment in the cloud. For this, we will have some accounts that we will set up, but each of the assignments will start with the way how you set up the account. That's why we give also the assignments out early, because the account creation will basically take some time here and there. It works not as expected, so we have to change it here and there. But usually the cloud vendors are very stable these days. When we look to Microsoft and Amazon credits, but there are always people that have maybe already used those credits or things like that. So we have to look on other avenues. Lecture 4 again gets us back to some conceptual elements where we really think about what is a data center that fuels cloud today. And of course, there will be lots of technology that we put in a very big data center, hopefully very close to some kind of dam or something where we get good energy from, because usually we will see the energy footprint of these systems matter. And we will look in things like that, that what is really the problem in these data centers, like cooling, for instance. Cooling requires in many of the data centers worldwide a large fraction of the energy that goes into the system. So computing more and more gets cheaper and cheaper when it comes to energy, especially if you think about GPUs these days that scale very good and also have a very low energy footprint. But when it comes to cooling, that's a different story. And that's why you will also see that more and more systems are also applied in the north or somewhere where it's very cold. Kajaani, for instance, in Finland is one good example where, of course, in Helsinki is the CSC system and the center, but they put their cluster in Kajaani, really in the north of Finland, because it's much cooler there in an old paper mill. So, and these are, of course, elements which is shared worldwide. And we look a little bit into some of these costs, but also performance metrics, so how it really scales, what to do with fault tolerance. We as a supercomputing center have already almost daily something that fails in terms of hardware. Now, if you have a scale like, you know, really Google data centers, they have errors every hour. So every system will fail continuously because of the scale. So how do you deal with it? You have to have a certain fault tolerance, keep operational. You cannot just shut down the data center and continue operating then in an hour when you have exchanged all the parts. It has to go on. So how you do this, how we will deal with this will be an important part of this lecture. Then also, of course, payment models, how you actually use this. Many of you these days are very familiar with these models, already pay-per-use, pay-as-you-go services. And the important thing of this lecture, however, would be also to think a little bit about what would be the cost of ownership if I would have my own data center, right? So these are things we will discuss. And then, of course, what people will expect in terms of service level agreements and sorts like that. A very important part, of course, will be security here and there, although I have to say, honestly, it's not a security course, right? So in other words, we will keep the security to a certain degree, but we will cover some of the aspects with private, public, and hybrid clouds, different aspects, how you employ clouds for getting data confidential, to ensure integrity, and lots of elements, how you basically can access these environments with SSH keys or had different accounts. But that's really it. And we don't have very much lectures about network security and so on, which of course all are very relevant, but which could be going beyond the core substance here. You see also Verne Global. This is a data center here in Iceland, very close to the Keflavik base. We will talk also in lecture 4 about it. And our goal is also, like 2 years ago, we went there. So this is something where we will do one-day event. And hopefully the most of you would be interested to join us in this event, and we can go to Vern Global and get a tour through the data center together, right? And a short explanation from the guys there, what they're doing, why there are some things very extremely secured. So you will find a data center in a data center and some not, and things like this. So it's maybe interesting because it's really a practical insight. We will also get closely to the computing center here of the university, but you can understand that this is a different scale. But there in the computing center of the university, we have of course more access. In Vern Global, you see lots of racks and a huge data center and lots of man traps and lots of security measures, but we cannot really go into the service. So this would be two things where we really touch metal, I would say, really see the systems beyond the cloud. Then looking more practical again, when we things like using technology for cloud computing, and there's a paradigm which basically stands the test of time. It's a map-reduced computing paradigm that is largely driven by Apache Hadoop and different versions of it today. We will looking in some scheduling aspects. Usually it's the idea of really crunching a big problem into simple tasks that could be executed in parallel. And then at the end, you want to have some combined output. So let's say you have all the documents that you have in the newspaper somehow in some data set. It is basically lots of big data. And you want to just have all of these reports which are talking about sports. So essentially that means you can break these into little different pieces, so-called chunks, looking through all the documents in parallel and sort this out where sports will be mentioned, where maybe soccer, tennis is mentioned. And in the end, you have a combined output of those reports. And it would take you much less time than doing it serial and looking through all documents step by step. Instead, you break it up in parallel. And this is what Apache Hadoop can do for you using the MapReduce paradigm. So we will spend one lecture also seeing what are the benefits with it, how to use it essentially with MapReduce in different areas of applications like computational biology for the BLAST application, but also in the web for PageRank, some machine learning applications and so forth. So this is also very broadly applied and mostly available in all cloud computing environments today. Then when it comes to the assignment 2, we will go to some other attractive technology that is out there today, which is by large one of the biggest user perhaps these days by cloud computing resources. And these are deep learning models. Also here we will start with some of the fundamentals. So what is artificial neural networks, the backpropagation algorithms and so on. And already, as I said in the beginning, the role of big data sets which are needed for deep learning. And so forth, but we keep it again to a reasonable degree. So no one in the course really need to know all the big substance of statistical learning theory. When you go later for a job in this area, that's a different story. Then you really should have a deep learning course or machine learning course, a proper one. But here we're really looking on it, how to really use it for getting some interesting applications done, which is, for instance, the things we have seen on the characters, right? The number characters recognition. So that just that you know how to set up such a system in the cloud, how to use such a system in the cloud. And there's also different aspects, not only images, you can also use it with time series data sets, like we did with Landsverkjön, for instance, with Gudmundur, where it's about power, energy. So this is something which is not images, it's more time series of data sets. And also these can grow quickly in size. So this is something where we have a, let's say, first introduction to deep learning, and also, of course, the practical packages that you will see when you go to the cloud environments. Known packages there are TensorFlow, Keras. Nowadays, Keras is inside TensorFlow partly. There's a new version of TensorFlow, although we have to be careful what systems are supporting which versions. So, of course, not all the systems are directly jumping on all the new technologies. And lecture 7 then will be really using these deep learning aspects that we learned in lecture 6 in some form of applications. There will be different ones, a couple of them from the remote sensing perspective, where also Rocco here on the call is basically one of the experts in this area, one PhD student of mine that is basically working on this a lot using deep learning. basically with large data sets in Earth observation. So here we will have some examples also how to interconnect different GPUs, not just use one GPU to solve a problem, but Rocco and basically his research is really using different GPUs together in order to fix a problem and to really significantly reduce the training time of these deep learning models, because otherwise he would be requiring days after days, and we break this down into rather hours. Then sequence data sets will be interesting because they are more computationally expensive usually because they have a recurrent neural network structure. Things like natural language processing are application environments about this that we will know. And then when we really want to think about what is killing in terms of computing time requirements, these are really neural architecture search aspects. So searching the real deep learning architecture from these models for a given problem in an automated fashion, AutoML techniques, which also then quickly goes to elements like transfer learning, where you learn something on one data set, but using it on another. This is something where we will tackle a little bit the way of how we use clouds for this massive computing time and how we can save with clouds and pre-trained networks some of this computing time. So this will be an interesting angle to see how clouds from the storage and computing perspective can help here. Then lecture 8 is again a conceptual one, which of course has some practical elements. Infrastructure as a service is something where you want to have, let's say, a very low-level infrastructure for you, and then you want to build on it. And you see that Amazon Web Services already gives you mostly 70 cloud services and even more these days, or more and more coming for just basically managing low-level aspects of your applications, like a simple storage service, S3, which is very well known. You will see even Gradescope and other systems, they use Amazon Web Services for this. They provide an additional application on top, but on the back end, they're using AWS services for data. And the same goes for block services or file system devices. We will have other IAAS examples, of course, but Amazon is by far, if you want, perhaps the best or biggest one known these days. So we will talk about it. We will use some of these services in some of the practical lectures. Platform as a service is then really the next level up, where you would say, I don't want to deal really with the very low level aspects. So rather give me some platform aspects to build applications, maybe a software development kit that should be always there. Or you have a credit card charging basically platform part, which is already there that you just want to dock to, and in order to get your application some commercial part of it, and so that people charge or can be charged for your services. So essentially saying this is a big Lego box, and here the Google App Engine is very known, especially if you think about that it's the back end of many, many applications in the Google App Store and so forth. So this is something where we will look in how games are really supported with this kind of idea. Things like Angry Birds, we will look in where we will see then, that is the really fueling mechanism in the clouds that is now fueling all the apps that you have on this thin devices you see here on the right, an iPad or iPhone. But what really fueling this in the apps is the tremendous power we have in the compute and storage infrastructures as the clouds today. And the platforms enabling really today very quick to create these apps and fueling this and contributing to the momentum that you have in these app stores today. Then really the highest level in clouds, if you want, is really the software as a service. So here we're talking about ready to run applications, which are, very much known partly. I guess many of you know the SharePoint or Google Docs, of course, but also Salesforce. Customer relationship management are very strong in this. And Zoho, for instance, you can do almost everything with it. It's basically in the business world, the modus operandi today. So you see more and more people using different cloud services. Like, for instance, if you have complicated contracts, nobody will just create difficult contract management solutions from scratch today. They just use Conga or another solution. So even Google Docs, there's Microsoft, of course, and others that have similar services, but a company is rarely nowadays starts from scratch and would just say we're recreating something like Google Docs for us. So essentially meaning that knowing these systems is important, but also knowing that you can create these systems, right? Like for instance, Conga, you see with online contract management, they found a niche market. So it was a company that saw some opportunity. And of course, there are lots of other SaaS solutions that I don't list here that are with smaller companies. So you could still think about that many of the things you want to engage with and perhaps in the future in the commercial setting could be ending up as a SaaS solution, because the usage model today is much more like this. So people hardly go in the inner city to some, let's say, store or retailer and say, I want to have this and that software. Or basically, as in former times, buy a game somewhere downtown. You rather go somewhere in the internet, connect to a cloud, and then you have your game or your software. So the subscription mechanism, licenses, and so on, which goes along the way with SaaS, is an important part to look at. And of course, is one way of an evolution of software development today, and also much more easier mechanism to really get your software into the world. In lecture 11, we will then look a little bit more on practical aspects again, also looking a little bit more towards the end, where, you know, assignment 3 is coming in, and where we want to have, you know, a lot of time in the end for preparing for the exam, then going for some assignment. That's why we also have another practical lecture around big data analytics, where you will then see that basically we have the opportunity to really get, you know, kind of different algorithms look in, and we will have then lots of interesting applications along the way. Docker container management, as I said earlier, this is already something with Singularity, Docker, how we really manage the scale of these clouds. So this is something where we have an insight how you really operate clouds. So we turn the picture at the end of the course really to something, if you are in the role to create your own cloud, what you have to do. You have to think about container management. You have to think about an OpenStack environment, probably about cloud operating systems. So all of this is kind of very important these days. Also, because it was very popular in the past couple of years, I brought one lecture on online social networking. So understand things like Facebook, things like graph databases will be one complete lecture where we look in how that really works, how it is fueled by big data and also using machine learning. And when you think about the streaming is another very modern way of looking at things, that we know that everything cannot be stored. We have to look at this one interesting item of information we really are interested in. And this will be also a complete lecture during the end of the course. But as you see, we don't do really assignments anymore with this. It's not that important in the course. And yeah, the epilogue will be then really the final lecture where we answering remaining questions, where we think about job descriptions, more on the mindset, skill set, and tool set level, recap of the course, and things like that. Right, so I think now I'm already a little bit over time, given the break and the later start, but basically that's it for today. Here is an interesting video, what is cloud computing, which I just will play now, but of course, because the time is essentially up, so please feel to leave. Or if you have some fundamental question, please speak now and we can discuss questions. The first questions I already got. Before I answer questions, you should get this one. So this is a team that here and there will be also partly working with you here and there and having a presentation. My research group members that are partly here, PhD students at the University of Iceland, but also partly in Germany. So that is of course very important because some of the slide materials will be also from them. And yeah, so that's really it. Any questions now from the audience? So we go back to the chat, and I would just say chat has some questions. So I tackle one question after another. The first question is, does this course have high requirements for programming ability? So this is not really deep and high requirements. So we have Python. We will do most of the assignments at a walkthrough. approach, which means there will be lots of Python code there already that you have to execute and then tell me what's happening in the assignment. Here and there you have to exchange some parameters. So that would be definitively something where you have a little bit of programming ability, but where you're essentially just switching parameters and try different things out. You don't create a C program with compiling and so on from scratch. You don't have a big Java programming coming. So here it's really understanding rather what the cloud is and so on. But it's a good question, and I hope I answered it. Otherwise, please feel free to send again in the chat. Are these books you mentioned available online for free, or do we have to buy them? So that's a good point. These books are really for those of you who are really extremely interested in this. Some of them are free online, especially now in COVID-19. I have seen some of them online, maybe more than in previous times, but also take away the message that you could survive this course without buying them or looking at them. Usually I put all the resources that I have in my, in my slides. They are quite full, so they actually are also like a script, more or less. So in this sense, I would say normally you should know everything by this when you have, basically not the books. The books here and there might be really useful if you want to dive much more into machine learning than we can do in this course. Just for an example, then you may or may not buy the book. But essentially what I'm saying is that you can say that this course can be really, tackled without really buying the books. I think 1 or 2 books from the beginning might be something you have to buy. But good question. Any other question maybe? Please use a voice or chat. Going once. Any more question? Okay, going twice. Don't be shy. Okay, if there are no questions, also feel free to send me emails in between. Of course, think about that we have our nice new Canvas environment here that I just share here shortly. You see there all the information, lecture Prologue, for instance, where I put lots of information, the slides and so forth. Take away the message that on Thursday will be a very specific lecture. I will share with you the online link shortly. I'm actually a session chair at the Europa conference at the same time where our lecture is happening. That's why I invite you to participate in this online lecture, which is actually a real scientific conference. Although you may not catch everything what the presenters may say, it might be very interesting for those of you who want to know the flavor of conferences, particularly now because they're all virtual and online. And the next really course element will be next Tuesday, where we do a little bit of a short introduction to Python and Jupyter, which is more a practical lecture from me showing you some elements of Python, NumPy, and using machine learning with it. It's more or less voluntarily to be there. If you have already in Python and Jupyter as a knowledge, then there's probably no point necessarily in attending this. Okay, so no questions anymore. Then the last which is left, I will play the video here and would say, see you basically on Thursday. Thank you very much for coming today and looking forward to really have the course together with you.
Cloud computing is the on-demand delivery of IT resources via the internet with pay-as-you-go pricing. Instead of buying, owning, and maintaining physical data centers and servers, you can access technology services such as computing power, storage, and databases on an as-needed basis from a cloud provider like Amazon Web Services. Organizations of every type, size, and industry are using the cloud for a wide variety of use cases, such as data backup, disaster recovery, email, virtual desktops, software development and testing, big data analytics, and customer-facing web applications. For example, healthcare companies are using the cloud to develop more personalized treatments for patients. Financial services companies are using the cloud to power real-time fraud detection and prevention. And video game makers are using the cloud to deliver online games to millions of players around the world. With cloud computing, your business can become more agile, reduce costs, instantly scale, and deploy globally in minutes. Cloud computing gives you instant access to a broad range of technologies, so you can innovate faster and build nearly anything you can imagine. From infrastructure services such as compute, storage, and databases, to Internet of Things, machine learning, data analytics, and much more. You can deploy technology services in a matter of minutes and get from idea to implementation several orders of magnitude faster than before. This gives you the freedom to experiment and test new ideas to differentiate customer experiences and transform your business, such as adding machine learning and intelligence to your applications in order to personalize experiences for your customers and improve their engagement. You don't need to make large upfront investments in hardware and overpay for capacity you don't use. Instead, you can trade capital expense for variable expense and only pay for IT as you consume it. With cloud computing, you access resources from the cloud in real time, as they're needed. You can scale these resources up and down to grow or shrink capacity instantly as your business needs change. Cloud computing also makes it easy to expand to new regions and deploy globally in minutes. For example, Amazon Web Services has infrastructure all over the world, so you're able to deploy your application in multiple physical locations in just a few clicks. Putting applications in closer proximity to end users reduces latency and improves their experience. No matter your location, size, or industry, the cloud frees you from managing infrastructure and data centers, so you can focus on what matters most to your business.